correspondingly, we had, I believe, a linear function for the bending moment in that first section cut that we took. And that one starts off here. If you plug in x1 is equal to 0, I believe you get 80. Then you ramp up here to the same location at point B. You have an equation of a straight line. I think it had a positive slope, if I'm not mistaken. 5.75 was the slope. So this goes all the way from 80 to 5.75 times 5, or 108.75. So there's our largest value of our bending moment so far. Now let's see what happens in the next set of values. So really, when we look at the next set here, we're considering what this thing is doing from 0 to 5. So typically what I like to do is I like to plug in the endpoint. So right here, the endpoint of this occurs at x2 is equal to 0, which really corresponds to this point, right, over 5 meters, because x2 starts right there, right? So plug in 0. What do we get? The same thing that we left off at. So we're still up there at 108.75. What happens at the other endpoint, at x2 equals 5? We plug in values. This thing is decreasing as we march along from x2 is 0 to x2 is equal to 5. So we're getting smaller, and in fact, at this endpoint, m goes all the way down to 0. So what we see is this parabolic shape. I did m first. So anyways, we have this parabolic shape coming down and hitting 0 at the end, which really corresponds to x2 equals 0 and x2 equals 5. So these are kind of our shifted axes down here. So this is our parabola. And basically, if you did this part, you'd be done, because that's all you really need to know for these bending moment problems is what's the maximum value. So we found that the maximum value happens right here. This is the one that we'd be interested in. Let's finish it, though.